class. I love making that noise at the beginning because I don't like the noise. I always start my video this way. Okay, we're going to talk about angles, angle measures, and so this is 1-4 and 1-5 will be about angle relations. So we're going to go through this video a little bit quicker because there's some definitions that are important, but you can see it pretty quickly. So in the beginning, it says a ray is part of a line. Essentially, a ray is you start at an endpoint, you start at a point, say M. An array is continuing that in one direction forever. Okay. Now, opposite this is in this case, if O is over here, this can never be. This would always have to be named MO. The dash this way. It can't be named OM because the direction matters. Okay. And opposite rays on a line. If you start at a point, there's going to be two opposite rays. MN should be arrayed this way, and MO is going to be arrayed this way. Okay? Actually, it could also be, yeah, that's fine, because JHJ. Okay? So you can do it this way. Okay? The arrow doesn't go the opposite direction. Okay? Okay? So angle is formed by two non-collinear rays. So they start where they share the same vertex or endpoint. So our endpoint's X. Sorry, that is not an X. Our endpoint's X, and we have a ray here. Okay. Notice how the ray curves. That shouldn't be happening. So this is why we use straight edges, because your teacher knows his abilities or his lack of abilities in drawing straight edges. So look at that beautiful thing. And so we take two rays and we get an angle. Now the beauty of an angle like this is we can actually measure it anywhere along the angle and we'll get the same degrees, same angle, okay? Same measure. Okay, so the sides, these rays are the sides, okay? This is the vertex. So vertex, okay, and the sides are over here and here, okay? These are sides. Sides. And this would be the angle right here. Angle, okay? Okay, if you have any questions, you can ask me. Interior and exterior, this is the interior angle, the exterior is on the outside, okay? So interior angle is on the inside of the two rays, exterior is on the outside, okay? That'll be important later on. We'll keep going because we have enough information to cover today. Okay, looking at this map right here, this is actually what we're gonna kind of focus on. Let's name all angles that have B as a vertex. Okay, so you see B right here. Name all angles that have B as a vertex. So that would be, that angle right here would be 1, or ABD. So notice, we can actually label angles as with the 1 right there, or the points along, so ABD, okay? Then also angle DBC, that's angle 2, okay? Name all sides of angle 3. So all the sides, so BC would be one side, or CB, ray CB, or CE, okay? You could also say ray CA, because that array is continuous, okay? It's collinear right there. What's another name for GHL? GHL. What's this right here? That's another name for it. Angle 7 or angle H. Or angle LHG. Okay, working right there. Sorry, I didn't draw this over here because it's in the document. So let's look at guide practice. What are the vertex of number 5? What's the vertex of number 5? You should say point C is the vertex, okay? 1B, name the sides of 5. Now there's two options, there's actually several options, so I'm going to give you one of them. So ray CG is one side, and ray CB. Now, are there two other rays? Absolutely. Okay, write another name for angle ECL. Angle ECL. Write another name for it. Well, angle ECL. It's going to also be possible to say that's angle for or angle LCE, or could say angle KCE. Is there one name we could come up with? Yes. So it can actually be any along those lines, okay? Okay, and then last one, name all the points exterior of the angle CLH. The points exterior to CLH. Well, what points are not found on the interior of that angle? There should be two. Point D, and I'll let you figure this one out for a second. Point D is also, then point E. Okay, if you're wondering about point A and B, that's actually going to be interior to the angle, okay? So point D and E. Okay, now degree. You see this beauty right here. This beauty right here. It's our protractor. Now we need a compass, protractor, and a straight edge from this class on. Just assume we'll be using them. Okay, now an angle is a degree is 1/360th of a rotation around the circle. Okay, so when we measure something, if I have a point here, if I make angle sorry, that was theme music for making an angle. Will not be repeated again. If you couldn't hear it, that's on you. Just kidding, that's my audio. Okay, so if I want to see the angle, the measure of this angle, I'm going to put my protractor right over the vertice. Okay, so I put the vertice right there, and then I'm going to actually see where it measures. Okay, so I have the line, and this is actually going to be roughly 20 degrees. I'm impressed. Why am I impressed? Because, I've got to be impressed with some things. Okay, so the other way you could do this is you could set up the base line. It's not the base. It's not called the baseline. You could set up the vertice and if you wanted to measure an angle, you put your protractor right over the vertice. If you want to get 50 degrees, you set your point right there. Line it up. And I made 50 degrees right there. This is 50. Okay. Okay. Now, if you notice, with degrees, we want to follow their method. Okay. Okay. 3 types of angles. Right, which is a measure of 90 degrees. Acute, which is less than 90 degrees, or fewer, less than 90. and obtuse, which is great between 90 and 180. Okay? Those three. We're going to talk about classifying in the next video, and we're going to move on. Okay? Thank you.